Hello, my name is Liam Osman, and I'll be joined today by Kayla Homanis, Tanzila Milky, and Tommy Lee to tell you about our solution to algorithmic bias in AI. Now, to get into the problem of what we're trying to solve, we know that algorithmic bias in AI leads to misinformation, cultural marginalization, and epistemic injustice across different languages and regions of the world. And we're going to be focusing on these languages and regions. Some of the basics, we know that languages have differences in semantics like sentence structure, gender of certain words, or slang and idiomatic expressions, which are not natively understandable in a translation. But with a little bit of work and knowledge, you can translate the meaning. The most important thing is that different training sets might have entirely different information and meaning within them. So that's what we're going to be focusing on. Different language sources tend to have different perspectives on certain topics and coming from different certain national domains. So if we ask an English source, it's going to give us information based on the US or a British perspective on something. Whereas in Spanish, it might tell us about the Spanish or Mexican perspective on an event. And these can also have different ways of solving some problems. Some countries and languages teach someone how to solve a math question a different way than each other. And this can give us alternative facts, which some people can argue is good in some ways, but is also bad. And so what can we do about this? Well, some of the effects we get is that asking an AI a question will often give you different results in different languages. And most AI answers are going to be biased towards the result of their own nations. For an example, here's what I asked ChatGPT about who invented color TV. In English, it told me it was Peter Carl Goldmark in the US, whereas in Spanish, it told me Guillermo Gonzalez Camarena, a Mexican, invented color TV. Another example, when I ask Copilot about Cuba in English, it gives me information from the CIA about its capital and population, what type of government it has, and some economy, that they speak Spanish. Whereas in actually a Spanish prompt, it tells me about some geography, what type of foods they make, and products like tobacco and rum, which Cuba is famous for. So that gives you a much more personable and insider look into information about Cuba, which I, as an English speaker, maybe I want to know that as well. There are also current efforts which exist today to try and alleviate this, but the details are unknown by these private companies in the black box of their algorithms. And by the examples I've shown already, it's still lacking and could use some work. There is a currently existing research about how to do cross-lingual prompting and maybe alleviate these and cross-reference between languages, but they haven't really been properly implemented in any significant or public fashion. So that's what we're going to try to do. Who needs this, though? Who can we actually help? Well, the Tampa Bay area has significant Hispanic influence in demographics, and it's only growing. Nearly 40% of Hillsborough County students are Hispanic. And with the growth of AI in education, even though teachers might not like it, students generally have access to limited models which suffer from algorithmic bias not representing their background.
And now, I'll walk you through one of the most urgent yet often overlooked challenges in AI, the ethics of it all. My name is Tanzila, and let's dive into why this matters. Like my partner has already showed you, asking two simple questions in two different countries gives you two completely different truths. This isn't just a technical glitch, it's a systemic bias. AI models, intentionally or not, reinforce dominant political and cultural narratives, depending on where or how a question is asked. And that's dangerous, because it shapes users' understanding of history, science, and even identity. This goes far beyond minor translation errors. We're talking about real-world consequences. Epistemic injustice, where users are denied balanced knowledge. Cultural marginalization, where smaller voices get erased. And algorithmic discrimination, where the system itself ends up favoring dominant groups, embedding inequity into the future of knowledge sharing. At the heart of the issue is deep data bias. AI is trained on internet content dominated by Western English-speaking sources. Worse yet, direct translation misses cultural nuance, and some historical events simply don't have a neutral version. And the truth is, major tech companies aren't even incentivized to fix this. The result? An educational system where bias is normalized, where certain perspectives quietly disappear, where cultural dominance gets passed off as neutral truth. Without intervention, AI will not bridge global knowledge gaps, it will simply just widen them. In short, if we want a fair and equitable digital future, addressing cross-cultural bias in AI isn't just optional anymore, it's extremely essential.
Hi, my name is Kayla, and I'll be talking about our solution. Our solution is to develop a free, web-based platform that uses a cross-lingual prompting approach to reduce linguistic and cultural bias in LLM responses. This will ultimately provide users with more fair and accurate answers that consider a wide range of lingual and cultural perspectives. For the features of our solution, we have multilingual source integration, which processes the user's query in various languages, manual source selection, which allows the users to select the specific language of the sources used to generate the LLM output aggregation. This allows users to receive a final single output, which we call a smart reply. And then for the usage limit, because we want to encourage users to choose our product, we're keeping it free, and users will be allowed about 40 to 50 prompts per month. Here's the user flow. So first the user navigates to our website, then they enter their question or prompt into the chatbot, then they can specify the language or languages of the sources used to generate the response, then they send their query and can view the smart reply from the chatbot. For the technical requirements, we're using Amazon Web Services for website hosting and setup. To integrate the chatbot into our website, we're using Amazon Lex. To translate the user's query into various languages, we're using Amazon Translate. To integrate generative AI capabilities and the LLM into our website, we're using Amazon Bedrock. And then for response analysis, we're using Amazon Comprehend, which will allow us to extract key insights from the LLM responses. And Amazon Bedrock allows us to aggregate these key insights into a single smart reply for the user. Here's our development timeline. So for the first 4 months, we're focused on integrating and implementing the technical requirements as discussed in the previous slide. And then for month 5, we're focused on system-wide testing, while month 6 is focused on user testing. And lastly, for future opportunities of this solution, we have 1, increased language support. Number 2, we can expand our model to work with more LLMs. Number 3, we can offer tiered subscription plans for different levels of features, usage limits, etc. Number 4, we can collaborate with different businesses and organizations and have opportunities for investment from these businesses. And number 5, we have potential for widespread adoption by schools internationally.
Overall cost of the entire project. There are 4 main Amazon AI features that we're using. The Comprehend AI allows us to implement topic modeling, which will cluster any prominent subjects within each response. This is good for detecting any common patterns within all the bias reports. Then we have the Translating AI, which is pretty standard. Then we have the Amazon Lex, which provides the user interface for the chatbot, while the Amazon Bedrock serves as the chatbot's brain, running the Titan model. The Titan model is similar to the OpenAI's GPT model. From the activity diagram, we can see that translating or analyzing multiple bias prompts requires making multiple API calls, one for each prompt. Because of this repeated call, the use of the Comprehend and Translate tools will be more excessive compared to the other services. When calculating the cost of each of these APIs, we go off based on this format. So currently, we would say there's 220,000 students within Hillsborough County. 33% are active users of AI. That means we only need to account for 72,600 users whenever we do these calculations. And as you can see from here, Amazon Comprehend would be about 29,000, Amazon Translate would be about 16,000. Now these costs is way more higher compared to Amazon Bedrock. Now when we calculate Amazon Bedrock, we take 5,000 input tokens and 2,000 output tokens. The purpose of this was to summarize all the bias prompts so users could understand every perspective from a concise way. We achieve summarization of all the biases by reducing the number of output tokens relative to the number of input tokens. And Amazon Lex is calculated similarly to the other APIs before. And from here, we get about 3,000 from both of the APIs. Now from here, for the total cost, we add all the API costs to get the total cost of the chatbot in total, which is about 52,000 here. The visual represents the month cost report of using all the AI tools from the AWS price calculator. Now, some ethical costs to consider is that our website is a chatbot, which mainly runs on a single domain. And due to simplicity, we don't need a virtual private connection or additional queries. Additionally, when implementing Amazon, we're going to be implementing Amazon Web Services to establish a server and manage all the backend through a domain name to access the address. And for security and protection, our website doesn't require users to input personal data, but we still require a firewall and a secure connection so we could protect users' IP addresses. And these are the additional cloud services we're going to need. The Amazon Route 53 establishes the addresses. Now it's cheaper, about $4, because we're only running on a simple domain or a single domain. Then we have the Amazon Amplify, which sets up a website or domain within an existing server, while Amazon Firewall protects the system from overload or malicious connections. Now the final cost would be employee salary. So we use the remaining $37,000 and distribute it to employees. Additionally, we would need to distribute it or space it out within a 4-month project period. So overall, they're getting $941 per month. Now this price would mainly be suited for part-time work. So overall, they're only working for 11 to 20 hours per week. Now overall, when you get the total cost of the model here, then the other API model or the other cloud services, then the cost of paying the salary, you get the total $100,000, which is suitable to the budget.